Welcome back, everybody. In the last episode, we talked about how you can code a for loop and a while loop. One very common application of a loop is to go over a list of things and then do something with that list, with each item in the list. So we're going to talk about how we can do that using arrays today. So what is an array? Well, let me show you. Basically, if I type int, let's say we want to get a list of prime numbers, okay? Prime numbers. Now, if I just start with like this, for example, that's obviously just one prime number. It's not multiple. You know, you might think you need to do something like prime numbers 1 equals 3 and prime numbers 2 equals 5 or something like that. But that's not going to work out in the long term. So what you need to be doing is instead turn this into an array. And we can do that simply by saying prime numbers brackets. The brackets have to be on this side. And then what you do, by the way, there's multiple ways you can create an array, but this is the easiest one to remember. So you put the brackets on the right-hand side of the name, and then you put curly braces like so. Now we've made an array. And this is an array of size 1 because there's only one item in it. But I can add a comma, and then I can add another item, and then another item, and another item. And now we've got, now I've got our array. Actually, that's not a prime number. So, yeah. There we go. So now we've got some prime numbers here. And it's got 1, 2, 3, 4, 5 items in that array. So you can think of it like this. How can we access an item in the array? We can do something like if I want to see out, and I'm going to do std see out like that because I got rid of the namespace because of Visual Studio didn't like it. So, but this is just a reminder you can do it this way. If you don't want to type in using namespace std, you don't want to do that. Just type in std right here. So just in case you forgot. So we'll do cout prime numbers, and then we can do our little, I think it's called the at operator. So we want to get the item at index 0, std and l. So something that might be confusing is that we're calling item number 1 item 0. You'll find in computer science we tend to start at 0 instead of 1. So this is just another situation of that. So if I output, I can do all of these in a row here, for example. I can do 0, and then I can do 1. And then let's think about the endpoint here. So this is 0, 1, 2, 3, and 4. So that's 4. So let's just hit play and see what we get. Yeah, 3, 5, and 13. And then here's the other code from last time. I'm just going to ignore that for right now. So we've got 3, 5, and 13. So that's good. Now what happens if we decide to access something that we don't have? Because we don't have 5. There aren't 5. Well, there are 5 elements, but the 5th one, since we started at 0, there is no 5th element. So what happens here? So we actually get something interesting. We actually get garbage data. We have gone outside of that array. So whenever you use something like a vector, a different data structure that we'll use later on, it'll just give you an error and won't let you do that. It'll sort of like crash. But here we're actually able to do that, and we get something kind of bad. So if you make a typing mistake, for example, that could totally offset the result that you get. If you're expecting something like 10 or 13, and instead you get negative 858,999, that's going to really screw you up. So don't do that. Make sure that you keep things within the range. Now, it should be worth mentioning that arrays can be used with not just integers, but with other data types. So we can have something like, I'll just copy and paste these in, but you can have a array of strings, like colors. And if I do this, this, and this, well, let's see what we get. We should get red, blue, and then some sort of garbage. Yeah, red, blue, and nothing. So, cool. And we can also do, well, I'll show you another type of array in a little second here, but let's try and do a loop. Let's do a for loop with this. So if I want to output, let's output all these prime numbers. So we'll do for int I equals 0. By the way, the I could stand for index. It could stand for iteration. I'm not really sure what it stands for, but people like to use I, either I or J or K. I is less than. So we want to, okay, remember last time that this is the initializer part, and then we have the condition part, and then we have the update part. So we definitely want I to increase every time, but what do we want? When do we want this loop to stop? We want this loop to stop when we have reached the last index. And as I said before, our first index is 0, so that's why we start with 0 here. So those are correlated. But then what is this one? Well, I could type in 5 because we don't want it to do anything when it's at 5. So as long as it's less than 5, then we're going to keep going. So then I can do my cout I. Oh, not I. We want what is it? Prime numbers I. There we go. And that'll be an indel. Okay. So here we're doing cout, and then we're getting the item at the ith location in the prime numbers array, and then we're outputting that. So if I run this, you will see that we are outputting everything in the array, just like that. So that is exactly what we want. Now, you'll also notice it could be annoying, for example, if this list changes, and this list has, like you update the list to add like another prime number in here, like 17. If you do that, then this obviously won't output the whole list. Or if you remove them, and then suddenly you'll get that out of range error, and then you'll end up with garbage data being output. So you'll want to figure out a way to output only up to the size of the array. And you can do that in C++ 17, which is 2017's version of C++. There's a nice little way you can do this. But I'll show you the old way of doing it, which is not very ideal. So I just copied and pasted this in there because it's a lot to type. But so we can get the size of the array. This is the old-fashioned way. You get the size of the array like that. So type size of, it's a special keyword, size of prime numbers, and divide that by the size of the first element of that array. That'll give you the right amount. And so even if we have an extra couple numbers on the end here, it should be able to output all of them. Yeah, there we go, 3 all the way through 19. And then if I delete all the way down to 7, we'll try that again. And now we've got that. So that's pretty cool. That automatically tells us the size of the array. If you're using C++ 17, you can take a little shortcut and just do std size of prime numbers. Size is different from size of. Size of will give you the number of bytes that the particular variable is taking up. Size, std size, will give you the length of the array. So just be careful for that. So if I do this again, you'll see that it will work. Yeah, 357, and then I'll add all the way back up to 13 here, and then you'll see that we get those two. Okay, cool. Also, just a side note, if you know that this array size will not change, then you can do something called const. And const is kind of nice because if you use this variable in any way that is like, if you decide to change this variable later on, the compiler will not let you. So if I try to do something like array size plus plus, it'll give me an error and say constant array must be modifiable value. So we can't try and modify a constant value or variable. So that's kind of cool because we will know for sure that this, once we get the size of the array, it will not change. Okay. That's just for this. So you can always try this again. Hopefully I didn't confuse you too much, because I can do something like Well, yeah, let's not dwell on that too much. But there's a way. It is kind of nice to have a constant modifier here. So yeah. Okay. One other note I want to cover is character arrays. So we've got 3 different types of character arrays here. And this also shows different ways of initializing an array. Let's get rid of that for loop, and let's do an output of these character arrays. So if I do std cout word1, for example, and then I try and cout all these other words, because a character is just a character, it's a letter basically. And so whenever you see something like a string, like we've had this before, std string color equals red, for example, all that's happening is this is just basically an array of characters. At least that's how it was in C. And in C++, they do a little more things with the strings, but you can essentially think of a string as an array of characters with maybe a little bit more to it. So let's output this and see what we get. These 3 different types of words here. Okay, so there's quite a difference here. And the first one gets us some garbage at the end. Oh, look at that. There's our red got appended onto that too. That's interesting. This one has a lot more garbage, and then with also red at the end. And code is finally output the correct way on the very bottom. So the important thing here is that if you're going to output a character array, you want to add the /0 at the end. And that /0 tells this output stream when to stop looking. So basically, this has been allocated, and some garbage memory has been allocated. And whenever we output word1 and word2, it doesn't really know when to stop outputting. However, whenever we output word3, the stream knows to stop when it hits that /0, and so that's all we get when we output that word. There are other special characters you can output things with, like there's the /0 is the important one. There's also going to be /n, which is for a new line, because you should be able to do something like code. Let's do test after that. We'll do a /0 there. So the /n puts things on a new line. Yeah, see, so we got code and then test. So code's on that one line, and then test is on the other line. And just to make this a little easier, well, I could get rid of this, and then you'll see that that is exactly what's happening. There we go. Okay. So yeah, code and test. So even though this is just one word or one variable, one character array, I have made it appear on 2 different lines by adding that /n and /0. So the /n puts it on the second line. /0 tells us to stop outputting it. /t is for a tab indicator. I wonder if that'll show up in here. Yeah, it does. So it's like you hit the tab button on your keyboard when you output it. So that's kind of neat for organizing data in different ways. If you have a bunch of words you want to spread out like a spreadsheet, you can organize it like that with the /n's and /t's. /r is a carriage return. I don't know if that's really going to show up on here or not. Okay, that's interesting. Yeah. So it returned, okay. So whenever we, okay, let me show this off. I think this is right. So let's just do T and E, and then you'll see what happened. Yeah, so /r brings the cursor back to the beginning, and so it overwrote the C and O with T and E. So there's some silly stuff you can do with that. Anyway, so that's just outputting those character arrays a little bit. And character arrays with the /0 on the end, those are known as the C strings. So this is what is referred to as a C string, because in C, not in C++, but in C, strings were like this. Strings are a little bit different now. slightly more stuff going on in them. But back then, if you want a C style string, that's what you do. Okay. And I just want to mention real quickly that there is more than one way to instantiate these arrays. So we've got the first way I showed you is just to have the brackets and then like that. You can also specify the number of items in the array like that, but I think it has to match up. Yeah, if it doesn't match up, then you get an error. And you can also just not even instantiate them like that. You can just say this is an array with 4 spots in it, and not specify what they are. But one thing I do want to point out is that if you say, well, regardless of whether you say it or not, this array cannot have more spaces in it than what you've already put in there. So this array called word1 can only ever hold a word with 4 letters in it, basically, regardless of whether or not you've specified 4 right there. So because it can infer that there are 4 letters right here. So if you want a word with like 5 letters, you need to make a new word, and then you do it like that or something. So that's one limitation of that. Strings, C++'s strings, you don't have that limitation. So I can say color equals red, and then I can change it to black, and it won't care. So it'll just expand itself basically. And we'll see more stuff along those lines later. But I just wanted to mention that just so you're not confused and that you know the limitations of what you're working with. Okay. So that'll probably be it for this video. It's getting kind of long. So we'll continue on in the next one with some more cool stuff. So thanks for watching, and don't forget to like, subscribe. See you next time.